digital signing. So you know the signing, right? You sign the documents, you sign your passbook, you sign your check, you sign the agreement, things like that, right? So if you sign a document, it means uh, you know what you have signed, and it basically proves that your sign is basically your identification, right? And it proves that that yes, this is Jay who has actually signed it. Okay, because I do signature in certain way, right? So this signature is my identification. If it matches, right, I sign a document, and if you want to verify that if it's actually signed by me or not, you can just match my sign. And if it matches, it means it is actually me who has signed it, right? In the same way, we have a digital signature. Okay, we have a digital signature that guarantees that the message that you are receiving through the public internet is sent by it is sent by the person who who is supposed to send it. Okay, and and how it works, it's almost same. Okay, what we have just now studied in the or learned in the encryption and decryption. Okay, so digital signature is, first of all, you understand that digital signature is used to establish the proof that it has been sent by the person who you are expecting to send it. If you are expecting to send a you are if you are expecting to receive a file, right, from Jay, then if my digital signature is matched with what you are expecting to match, then you will know that yes, I'm pretty sure, 100% sure, 200% sure, because that this file has been sent by Jay. And why you are 100% sure? Because in that document or the message that you have received, it has my digital signature. Okay, so let's understand what is digital signature and how it works. Okay, so just now you understood that what happens. Okay, what happens in case of encryption and decryption. Okay, what happens in the encryption and decryption? So this is your sender. Now you need to understand this very well. Okay, this is your sender and this is your receiver. You got it? So encryption and decryption, what happened? This person has generated a public private key pair, right? Right? And he sent this public key to the sender, right? This is your key pair. Okay. So this guy will use this key to encrypt the data. And I'm not going to repeat the encryption part again because I have to repeat anyways in the AS2 explanation. Now we are going to understand the signing concept. What happens in the signing? Your sender, okay, your sender generates a key pair, okay, okay. it is public key, and this one is private key. Okay, this is public key and this is private key. He want to he has a message that he want to send to sender. Oh, sorry, to the receiver. But before he sends, you got it? This is your plain text. Plain text. And you will be using this. Okay. So uh, uh, you will encrypt this data and send to the receiver, right? But your receiver also want to make sure that it is actually receiving the data from you only, right? And he want to be 100% confident about that, right? So he will ask you to sign the document, right? So now let's understand how this signing works. Okay, so this is your plain text. Okay, so before this plain text sent to the receiver, it will be encrypted, but we will see it later. So for the signing, what happens? There is something called the hashing. Okay, so in hashing, what happens? You have a very long string, say suppose. Okay, you have a or 1 GB file. Okay, yeah, or 1 GB file or 1 TB file. Okay, you have a hashing algorithm. You have a hashing algorithm. Using this, if you apply this hashing algorithm on your message, okay, then your hashing algorithm generates a small string. Okay, not 5 or 10 digit string like 100 digits or 50 character string, or string or number, whatever it is. It generates a hash number. Okay, so this is your hashing, hash number, hash key. Got it? Okay, so if you apply this hashing algorithm, it generates a hash number. Okay, now here's another important thing. Your hashing algorithms are created or has been created in such a way that it always generate unique number for every single message or every single file. Okay, it generated it generates unique number for every single file. Okay, hashing number for two different messages or two different data or two different files will never be same. So as simple as that, right? So this is your hash number. Okay, next what happens, do you see this private key that your sender has generated? It uses this private key and this hash number. It adds these both. Okay, and with the help of an encryption algorithm cipher, it encrypts this hash number. Okay, so with the help of hashing algorithm, a hash number has been generated for your plain text, and then that your hash number is encrypted with your private key. Okay, so this is your encrypted hash number. Okay, your sender has to provide this public key to your receiver. Receiver has your public key. Okay, next what happens? Your sender then will go ahead and it will encrypt this plain text file. Okay, it will encrypt this plain text file. How will encrypt? With using this public key. Okay, then what he will do is he will make one envelope. It will add this encrypted message and this uh, encrypted, okay, encrypted hash key, and it will send this entire message to your receiver. Okay, your receiver will first decrypt this message. Okay, how it will he will decrypt? He will decrypt with his private key. Okay, after decryption, it will get the plain text or original message, plain text. Okay, next what will happen? This guy, your receiver, okay, will use the same hashing algorithm. Okay, and generate the hash key, hash number, or it's actually it is called only hash. It will generate the hash. Okay, beside this, after doing this, do you know what will happen? Your receiver will take this. You know that, right? I don't know, I tell you or not, your receiver will receive this entire message. So it will receive the encrypted message as well as encrypted hash. It will decrypt this hash. Okay, it will decrypt this hash, and how it will decrypt? With the public key of sender. Okay, now because this has been decrypted, now if it's decrypted successfully, so that is our first success. After decrypting, right, your sender will match this number and this number, or I will say this string or this string. If both matches, it means you have valid signature and your file has been sent by the person who actually supposed to send, right? And how it is proved? Simple, right? You encrypt this small number, so you have 10 GB of file. Your hashing algorithm will have, say, suppose 20 digit number or 50 digit number, right? This 50 digit number is immediately decrypted by this key, right? If it is decrypted by this key itself, it means it is sent by somebody who has the private key of this public key, right? And the private key of this public key is with J only. It means this message has been actually sent by J, right? And to verify that I have right hash number, I have uh, calculated the hash of original text. Okay, now actually it proves one more thing. As I told you, hash of two messages or two files can never be same, right? Now if you apply the hash algorithm and you get the same hash number from this plain text, it means this message was not tampered by anybody in the public internet, right? Why? Because your hashing algorithm has generated the same number, okay, has generated the same number as it was generated by you. And you know that two different messages or files will never have same hash number. They will always different. But two similar or two same files or same data will have the same hash number always. So if the hash number is same after uh, decrypting the data, it means use whatever you have sent, I have received exact the same replica or the copy of it. So your signing prove these two things: identification and the validity of your data. Okay, so this is the signing. So you need to remember just one thing: encryption happens. Your sender will encrypt the data with the public key, but it signs the data. With the private key, its own private key. Oh, any question? I know it's a little confusing, and it is confusing, right? But if you listen our session again, you will able to understand. But this is what it is. I mean, I tried my best to make you understand. Sorry. Any question?
In real time, we use the hash key a lot. Or
Say again.
in the real time,
Uh-huh.
we use the hash keys a lot.
Hash key. I mean,
Yeah.
what is the hash key? It is hash. We call it hash, right?
Yeah.
Are you talking about this number?
Yes.
Yeah, definitely. In real time, this is how actual signing works. Actual signing,
Okay.
right? So your plain text, right? Using a hash algorithm, hash will be generated, right? The number generated after applying the hash algorithm on your plain text is called the hash number. Okay, and yes, this is how it actually works, and we will see this is how it works. Okay.
Yeah.
Okay. Supply, any question?
No, Jay.
Okay. Okay. So this part completed. Now let's understand AS2. Take a picture of this. Okay, just take a screenshot of this, because I will ask you again and again to look at this diagram. Okay, come over here. AS2. Now we are ready to learn AS2. Okay, this guy is receiver. This guy is sender. Okay, and they will send a file through AS2. Okay, what will happen? He has a plain text. Okay, plain text. Okay, he will this is a public private key, and he will also have a public private key, right? And so in the first step, what will happen? Signing. Signing. So a hash algorithm will be applied. Okay, and it will calculate its hash number. Hash. Okay. After that, okay, and this. Okay. After that, what will happen? Your sender will use his private key. And this is public key. This is private key, and this is public key. Okay, this is your hash. He will use his private key, right, to encrypt this hash. So this is encrypted hash. Okay, then this guy will take this plain text and okay, what he will do? He will take this plain text and this public key. Okay, he will apply on the message to encrypt the data. Okay, after doing this, what will happen? This part and this part means encrypted data and encrypted hash key will be sent to your sender. What he will do?